Okay, hello there guys. Welcome to another C# tutorial. In the last tutorial we have seen how we can call functions. In this tutorial we are gonna see how we can build our own function. Now let's say that for some reason you want to create a function that performs an addition of two integer numbers. Okay, so let's say you want to do something like this. Int c equal add a, sorry, let's say 4 and 5. Okay, you want to do a function like this. Okay, so obviously you have the name over here and you need to specify two parameters, and the function will add these numbers together and return the value as integer. So how do you do something like this? Well, you could first specify the return data type. Here this function should return an integer. Okay, so you write int. Followed by that you write the name of the function. In this case you write add. Now you open a bracket and you mention all possible parameters for this function. Okay, now in my case here I opened and closed the bracket and there are no parameters in between, so I have to put parameters. Now what's the data type for the first parameter? It's an integer and I'm gonna call it n1. What is the data type for the second parameter? It's also an integer and I'm gonna call it n2. Okay, so far so good. Now this function now should perform the calculation, so I'm gonna say int n3 equal n1 plus n2. So we have just added these two values and we have finished the calculation. So now this function must return the value. So I'm gonna say here return n3 and semicolon. Okay, it is as simple as that. Okay, now still this one is not working. I suppose I need to put public. Let me see. Oh no, it's not public. I need to say static. Oh, there you go. This should do it. Okay, yes. Okay, so for now, don't think too much about this keyword. Just put it there, and that's it. So let me recap this quickly. You specify what kind of result the function returns. You specify the name of the function. You open a bracket, and then you specify the data type and the parameter name for each value being passed into the function. Now the function will work on these values and return the value to you. Okay, so in this example, let us test this program. And now we would say system console write line C, and then system console read line. It's as simple as that. Now let us run this program. So we are getting the value 9, and obviously 4 plus 5 equals 9. So far so good. Now, so what is happening here? Let us just clarify things. When your program runs, it gets into this point. So it needs to get the value from this function and put it into C. So the execution, the pointer or execution pointer will stop at this point, and think about it like you will mark this location and the execution would transfer into this location. 4 will be placed, this first parameter here 4 will be placed into n1. The second parameter here will be placed into n2. Then we will use these values to add each one to the other, and we will return the value here into C. And in order to see the value of n1 and 2, we would write something like this: system console write line n1 equals plus n1 dot to string. There we go. And then we will also print n2 so that we can see what's going on. So you can see here n1 is 4 and n2 is 5, right? So here we called 4 and 5, as you can see in the add, right? And when the code went to this part here in the function, we are printing n1 and n2, 4 and 5. Now if we flip these parameters, obviously the values we are gonna get are reversed, obviously. Okay, so 5 and 4. Okay, just in case it wasn't obvious for anyone. What this means is that the first parameter goes, the first value here are placed into the first variable, and the second parameter here goes into the second variable, and so on. Okay, now one of the things you might, let's say your code becomes a little bit too big, so you start forgetting what the function does or what the order of parameters are. So if you open a bracket, you can see here it says int n1, int n2, so you could remember here. In our case, you won't. In our case, we chose, you know, a generic variable names. However, if you are writing good code, usually you would use a descriptive name. Okay. This is one thing. You could also try to do this trick. You put this forward slash 1, 2, 3. Okay, after you add 3, you will get this kind of commenting system. Here you would write what the function does, adds 2 numbers. Okay, and then here you would specify what's the first parameter, the first number uh, to be added, and this is the second number to be added. Now this does nothing to your program at all. Okay, however, when you are writing your code, let's say now I forget what the function does. So here I'm going to say add, and I will open a bracket. Now check this out. When I selected the add, what appears here? Adds to number. You see, this is the comment. So now I know what my function does. Okay, and you open the bracket, so you see that the first parameter is highlighted, and what is n1? It is the first number to be added. Okay, so you can remember what the parameters are. Okay, and you put a comma, and now you go to the second parameter, and here it says the second number to be added. You see, so this way, even if your code is a little bit big, you won't have to, go back and check your code to remember what the parameters should be. This way, if you do it correctly, if you use this technique or provided by Microsoft, uh, you know, things will be much easier for you in the future. Okay, so this is the simplest example. We're adding just 2 numbers. So far, so good. Now, let us try another example. Instead of using this add function, let us, for example, create a set of useful functions for, let's say, factorial. You want to calculate the factorial. So I'm going to say static. Now, what does the function of factorial receive? Or usually you get a number, let's say 4 or 10, and you calculate the factorial. So there is one input, which is one integer, and you get one output. First, I will assume it's an integer. Okay, factorial usually you try to use double, but if you use integers, I want to use integers to show you the problem. Okay, factorial here. Now, what are the parameters? I'm gonna say int n. There you go. Okay, so now what am I gonna do here? I'm gonna say int f equal 1 for int I equal 1, I smaller than n, and smaller than or equals to n, and I plus plus. So here we have f equals f multiplied by I. There you go. And after this function finishes, we're going to return what? Return f. There you go. Next, we will add some comments to make the code readable. Calculates the factorial of a number. There you go. And here n, the number to find the factorial for. Okay, it's as simple as that. So now we have this one. Now we are going to change this into factorial. There you go. And open. And let's say factorial of 5. Okay. So now we will run this and see if it gets us the factorial. So the factorial of 5 is 120, and actually 5 by 4 is 20 by multiply this by 3, it's going to be 60. Multiply this by 2, it's 120, so it's accurate. Okay, so far so good. Now what happens if we increase this to 10? Okay, it's working, no problem. Let us increase this to 14. No problem, it's working. And I'm gonna make this factorial of a 20. Okay, so now when you check this out, when we try to calculate the factorial of a 20, we got an error, and this is because of overflow. Okay, we didn't get an exception in this case, but basically there is a limit for the numbers that an integer can store. For this reason, you don't use integers with factorials. You'll try to use double data type. So here we have double. This should return double, and obviously this should be double, right? And yeah, it should be something like this. Let's try to run this code, and now check this out. It's 2 point blah 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 multiplied by e plus 18, which means multiplied by 10 to power 18. So there is 8. You have to move the decimal point 18 digits to the right. Okay, so this is a very big number. Okay, but this is just basically the scientific format for writing them. Okay, so again, what we see here is that we specify the return data type of our function, the name of the function, open a bracket, write the parameter specifying the data type and the name of each parameter, closing that, and so on. Now, let us try to make another function here. Okay, we will create a function that will increase a variable by 1. It will not return anything, but it will increase a variable by 1. So I'm going to say static. Since the function doesn't return anything, we should write void. This void means the function doesn't return anything. I'm going to say inc. I'm going to say int n. Okay, I'm going to say n plus a plus. This function increases a number by 1 only. That's it. Okay, the number to increase its value by 1. Okay, that's it. Okay, so now what are we gonna do here? I'm gonna say int n, or let's say c equals 0, right? I'm gonna say inc c semicolon. So check this out. We will put a number over here. We will place a 0. We will call this function and increase the number. Then, after finishing the execution of this function, we should display the result. So let us run this. We are getting a 0. So let us try and trace the program. So I'll put a breakpoint here. I'm gonna run this. Okay, so what's the value of C is 0. I'm gonna say step into. So C is still 0. Step into. There you go. So N is still 0. It's the same as C. I'm gonna step go. So what's the value of N? Now N is 1, but C, okay, uh, we won't get C until we get back to the main program. So we get this one and we get this one. So what's the value of C? Still 0. So I wanted to show you this because when you are passing variables, uh, you are passing a copy of the variable here. Okay, so here you get a copy of what is in C, and that copy is placed into this variable. That's it. Okay, and this is why, although we are increasing the parameter here, the value of C stays the same. Now, what if you want uh, the variable to be linked? For example, C here should be affected by the increase over here. Well, you just need to add a this keyword ref, reference. Now, and when you call the function, you should also write ref. This stands for reference. It means that this call is by reference. When you hear the term a call by reference, it means you are not sending a copy of what is in the variable. You are sending a pointer to the variable. Okay, so now N and C will point to the same location in memory. So increasing N or C means the value in that same location will be affected. Okay, so now let's try this out. Let me run the code without anything and without any debugging, and then we will see. So you can see now the value, instead of 0, it's 1. Now let us trace it and see what's going on. So place this one here. We'll call this. Okay, so C right now is 0, right? So let's go step into, and now we're gonna call this. There we go. So now what's the value of N? This is 0. What's the value of C? You don't know right now, right? So we will increase this variable by 1. So now N is 1 instead of 0. Let's go back to our main program. Now what's the value of C? You can see now the value of C is 1. And the reason is this reference keyword. This reference keyword tells the computers that whenever this variable changes, okay, this one will also change as well. Okay, yeah, and in some cases you will need this behavior. In other cases you will need the standard behavior, which is like this call here. Okay, so just keep this in mind. Okay, now you might be asking, well, here I'm trying to increase a variable. This is not a very useful example. Well, now we will get into a useful one. What if you have two variables and you want to find which one is bigger? Or let's say not bigger, I'm sorry. You want to swap two variables. So here we're gonna make a function that swaps two variables. I'm gonna say void swap ref int and 1 ref int. Oh, wait a second. I'm gonna use a ref int b. The reason is I don't want you to think that I have to use the names N1 and N2. You can use any name, okay? So here, just for simplicity, I'm using different names. That's it. Just want you to know you are not restricted to these names. You can choose any name you like. So we are gonna need a temporary c equal a and a equal b and b equals c. Okay, now this code will swap the two variables. I think we have taken an exercise regarding this before, but this is how you do it. Okay, now one of the things I want to tell you now, if we have this c over here, no problem, and let's I'm gonna use x over here, x equals 10, int y equal 20, and then I'm gonna say swap x and y. There you go. I should use the ref keywords. There you go. Right line x, right line y. So if the function runs correctly, we should see 20 followed by 10, not 10 followed by 20. Now we are running this, you can see 20 and 10. So let us trace this program and see how it's running. Okay, so I'm gonna run this. Okay, step. Okay, there you go. So we have 10 stored in x and 20 stored in y. I'm gonna call the function here. There you go. We have what? We have 10 in a and 20 in b. There we go. We define a new variable c. We put a into that. We put b into a and c into b. That's it. And we get back to the main program. Here now we have 20 and 10. So all is swapped and all is working fine. No problem. Now, just one important thing I want you to think about here. I used x's and x and y here. I can still use a, b, a, b, a, and b. Okay, so now I want to tell you something. These variables, the a and b here, okay, are not the same as these a and b variables in this function. They are linked by the ref keyword, but they are not the same variables. Let me show you this. Let me prove this for you. So now, right now, we are gonna run this. A, B. Okay. So now we have A is 10, B and is 20. Let me run here. So now we have A is 10, B is 20, right? It's the same so far. Okay. Now, if we change the program, you will see the difference. I will use B and I will use A. Okay, so there's a B here, A. Okay, check this out. What do we have? We have A and B. So let me run the code again and step into. Now we are gonna call this function. Check out, B is 20 and A is 10, right? B is 20 and A is 10. Okay, so now we will go into the function. Now check this out. A is 20 and B is 10. It's the reverse of what was in here. The reason for that is the computer doesn't understand what the name of the variable is. It uses the name of the variable just to distinguish the variables in the same block. As far as the computer is concerned, there is a variable over here. Okay, it has some memory location. However, the computer has no clue that there is another variable in this block of code that is also called A. What the computer does when there's a function call, it will take the very first parameter, this very first parameter, it will copy or pass the reference of this variable. So it is passing the reference of B into this function. Okay, in other words, this A and this B is a totally different variable than this A and this B. And to give you an analogy, I'm sure many of you met people who have the same names. Let's say there's you have a number of friends, and it just so happens that two of them are called Smith, right? So you have two people having the name Smith, or maybe two or three people having the name Todd. However, these are these are different people, right? So if you go to the address of the first person, you'll find that there is Todd, and that Todd have his own car, he has his own job, and he has his own stuff, and so on. You go to the second person's house, although he's also called Todd, but he have a different car, he have different stuff, and so on, right? So the same thing apply here. These variables, although they have the same names, these are independent. Okay, so when you are calling these functions, you are linking, if you are using, let's say, the reference parameter, you are linking the first parameter here and in the function call with the first parameter here in your actual function. Okay, and the second parameter here with this one. Okay, so it's like you made B connect with this A and made this A connect with this B. Okay, so this is one important thing that you have to realize. Okay, some programmers get confused with this, but after a while, if you have enough experience in programming, you won't have any problem later on. Now, one of the things that you might hear is local variables. Okay, uh, well, these are called local variables, and the reason they are local, I mean, C here is a local variable, A and B is also local variables because, or you could think of them as local variables because they live only in this block of code. This is their home. This is the home of the A, B, and C. Only these A, B, and C. Okay, and for this block, uh, you will find that for this block is the home of this A and this B only. Okay, this A and B is independent of this A and B. Okay, so keep this in mind. Don't get confused uh, with this thing. Okay. Uh, okay. So I think I'm finished with writing your own with the subject of writing functions, but I would like to show you something interesting here. If we look at our previous programs, what you will find is that we usually find this code written for us. There's a static void main open brackets string square brackets arguments and this is close, right? So check this format. There's a static here, there's static here, there's a void here, there's a void here, there's a swap here, there's a main here. So basically what you have been writing in the previous exercises or previous tutorials was you was writing functions. Okay, you were writing functions. Okay, and here you open a bracket, you have a predefined parameter. Now one thing to keep in mind is that this main function, this is a standard function that the program start running from. Okay, yeah, so I think that will be all for today. Probably we'll have more exercises regarding writing our own functions in the next set of tutorials. Okay, so I hope you will find that this video is useful. Thank you for watching and have a nice day. Bye bye.